Welcome to the session APS401, Empower Innovation and Agility with Security into DevOps. I am Maria Ann, Senior Security Solutions Architect from Brazil, and here with me we have Vinicius Golin, a Senior Solutions Architect from Brazil. So, we have this agenda today. First, let's think, should the lack of security be considered a defect? Also, we are taking a look at how AWS does security into DevOps. We are talking about security in the pipeline and off the pipeline. We are seeing the deployment pipeline reference architecture. We are going to see the demo of this architecture, some code running, and also we are going to dive deep a little bit into the code. Let's start with a quote from Werner Vogels, our VP and CTO. He mentions that security is everyone's job. Now, it's not just the job of the security teams. If you heard the keynote yesterday, you saw this message. We are talking mostly about the security goal to the developer's ownership. But there are ways to help them, to empower them, and we are going to see this today. We are going to see architecture and code. But first, let's start with, should lack of security be considered a defect? What do you think? Yes? Yes? Okay. We are not going to enter in a car or in a plane if it's not secure, right? So why do we should treat software differently? We can have like data breaches, we can have loss of intellectual property, we can have service disruptions, and all of these are going to incur in loss of our customer trust or costs to the business. And because this, we need to think to fix the security defects as any other defect in the software development lifecycle process. It brings us to devsecops, or security into development. And DevOps is like a cultural philosophy. There are some tenets and practices, and there are processes and tools that are going to support this. We are talking to use automation to support the business agility. And we are talking to apply security controls that make sense for us, to have the security policies validated against our process. With DevOps, we can deliver fast. There are some metrics that we can bring the value from some months to some weeks. And when we talk about bring value, is the customer using like our service or maybe our application, some value that we are delivering to our end customers. We are also talk about immutable productions. It means that the same code we develop, we are going to pass for a lot of tests in a lot of stages and deliver this in production. And it are going to be tested like for many steps during the development lifecycle process. This picture shows that security should be involved in all the development lifecycle process. We are going to have the confidence that we validated our workloads through all the process of the development, in all steps of the development lifecycle. We are going to have consistency and repeatability to our security policies. We can have like a lot of codes or inputs. We are going to do the same tests in all of this, using this pipeline reference. Also, through this, we are able to achieve security at scale. When yesterday we saw in the keynote the shift left term, and shift left means we are bringing the security more to the beginning to the development lifecycle process. And this image shows this. We are thinking from security since the planning and putting into all the steps. How can we achieve this? We can do this, first of all, driving cultural change. And once more, you heard this in the keynote yesterday. We saw some customers in the stage talking about this, about cultural changes. And this is very important to mention. We have some tenets when we talk about DevOps and DevSecOps. First of all, we need to break cultural barriers because we are talking that development, operations, and security need to communicate and work together to support the business agility. We need to deliver value to our end customers. We need customers use your systems and applications. So to support this, we need to collaborate, communicate, and work together. And this is the culture process. This is the culture part. We have the process part that's treat infrastructure as a code. We need to use code to build everything, including our pipeline. We are going to see this today. We need to rely on automation. We also are going to see this today. And we need to test, measure, and monitor, because we can just improve what we measure and monitor. And when we talk about test, we are talking to test security and test security early. You need to do security by design, and you need to test this since the beginning. It's part of shift left. And we have the tools. The tools that we are going to see today are going to support the process and the culture. We also have some security tenets. We need to prioritize preventive controls. It's better if we can prevent and do not need to detect, okay? If I need to prevent someone to enter here, it's even easier than I need to put this person out, for example. So, we also have to detect and respond, because preventative controls sometimes can be not enough. So, we need to also learn, detect, identify, and document what we have get from this experience to detect some security event or operational event. And here we have our start of the day, the pipelines. The pipeline is really where we are going to construct using code. We are going to put some code in the beginning, do a lot of tests, including security tests, and this is the part that we are going to focus today, and we are going to deliver value in the end. As I mentioned, our customer using something meaningful, something that we built for them. It's important, as I mentioned, to measure. And when we talk about pipelines, there are some metrics that you need to think about. There are some metrics that's related to velocity, the frequency that I'm going to deploy something. Like, do I deploy in production 3 times a week, 3 times a month? This is a metric related to velocity. Lead time for changes, the time from a single commit to go to production, to run through all the pipeline and go to production. This one is also related to velocity. And there are 2 metrics that are related to stability. The change failure rate, that's the percentage of failure deployments due a period of time. So for example, if I run in 2 weeks, 10 deployments, and 2 of them fail, I have 20% of failure rate. And the time I spend to restore a service that have some disruption in production. If you have these metrics and you keep monitoring these metrics, keep measuring, you can improve, during the time, you can improve your business outcomes. Because what we want is deliver fast and with quality. And when I talk quality, I also talk security. Security is inside of quality of our software. As we see, security defects should be considered as any other defect. How AWS does security into DevOps? There is no right or wrong, but it's the way that works for us, and we see this working for other customers as well. You also heard this from keynote yesterday, some customers talking about this, that security culture is different from culture of security. We do not want the security culture of one specific department. We want that, as Werner Vogel's quote mentioned, security be everyone's job, including developers' job. And to be developers' job, we, the people from security, should help and enable other teams. So ownership is the key to enable security at scale. Everyone needs to have ownership of security. In AWS, we have our service teams that run the services and products, and they have ownership of what they run and build. These teams are empowered to innovate. And we have the security team. The security team enable these teams to innovate securely. They are the owners of the overall security organization. And for example, let's talk about threat modeling. When I talk about threat modeling, who knows the application? Because we have a lot of applications with different languages and codes. And usually the service teams are the ones that knows very well that code and that application, right? At this point, it's much more easier for them to learn how to do threat modeling, and the security team enable them to do this, so they are able to do security reviews. And at this point, when they are going to production, you heard about security reviews yesterday in the keynote. We do security reviews to put things in production. But at the moment that security team are going to do the security review, the service team has already did everything because they know how to do, because the security teams enable them to do this, okay? We have some practices here. Treat infrastructure as a code. We saw this, we saw this yesterday in the keynote. We see this all the time. It's very important because with security, with infrastructure and security as a code, we can define guardrails. And we want to define guardrails and not gates. Gates stop people. We do not want to stop people. We want people to be able to be agile and innovate. We want to establish the security controls. And we need to know which controls are we going to apply, which controls are we going to have, so we can automate them. We can put them as a code, and automate as much as possible is one way we are going to scale. For sure, wrap security around the pipelines. And this is our main topic today, security around the pipelines. Let's start with the security of the pipeline. Securing the application starts with securing the pipeline. Why? If you have a pipeline that has a lot of tests to test the security of your application, and you just allow someone go there and modify the pipeline, you are not going to guarantee the security of your application at all. So, pipeline is a workload, and the purpose of the pipeline is integrate other workloads and delivering, test and building and deliver something in the end, the application running. We have data, infrastructure in the pipeline, right? And we need to think about who can do things in the pipeline. How can I prevent pipeline to be modified? And at the moment that I define pipeline as a code, I am doing this. I put some guardrails here. If people want to modify the pipeline, they need to change the code. And I have also least privilege. I have some validations. If I have pipeline as a code, I also can run security validations against the code of the pipeline. So at this point, we are really achieving security. Here is important to mention also encryption. We need to ensure encryption at rest and in transit. For example, use HTTPS. When we talk about encryption of the artifacts, the pipelines produce some artifacts that are running through the beginning to the end. We are going to see some of them, but you need to encrypt these artifacts. It's important to think about this. Also, if you are running your pipeline in some server in an EC2 like Jenkins or OWASP Zap, you need to ensure that you are doing patches into this machine. And you need to put this in your process to patch the machines of your servers. It should be part of your daily by day process. And we have the security in the pipeline. And Security on DevOps is achieved by integration and automating the enforcement of preventive, detective, and response controls into the pipeline. What did it mean? The same image again. We talked about shift left. Feel free to take pictures now. We are going to have secure tests with other tests. In this slide, you are seeing, for example, that we have unit tests, and just to show you all the development cycle. But there are some highlights here. There are the secured part, the secure tests. And you can start in the developer machine, because you can put some hooks there that you can validate if the developer, for example, put some access key or some secret there, and you can validate this even before you commit, okay? You are going to have, for example, the build stage, and you can start test in the build stage, okay? You can generate a software bill of materials, for example, with all the third-party vulnerabilities list. We can test during the release. You can do some hash verifications into deployment. It means if you sign your artifact when you generate it, you can validate at the moment that deploy if it's the same artifact, if no one tampered with your artifact. At the moment that you operate, you can do compliance checks. For example, in AWS with config, you can check for changes in the configuration, you can apply rules, and you can respond using automation. And for sure, in the monitor, you can do penetration tests. But you can also do some penetration tests before. So you can put secure tests in a lot of steps of your development cycle. This is the message here. What makes sense for you? We are going to show you here a reference. And now I use it to be a developer. And now I am going to show you my t-shirt here, okay. Hope you can read it. I turned coffee into gold. I use it to do this, to help me to stay more secure and to show you this demonstration of the deployment pipeline reference architecture. I have here with me Vinicius from security team. We are going to work together, development and security.
Are you going to do that? All right, so we're going to do the same thing. We are security guys, so here it is. Actually, the thing that we are saying here is it's really, we don't want to have this difference. We don't want to have, we are not going to say, okay, I'm from security and she's going to say I'm a developer. This is exactly what we are proposing here, okay? Let's work together. That is the real thing, okay? Thanks for having me, guys. I'm Vinny Golin. I am also a solutions architect within AWS. And let me tell you what is in front of us, okay? What we are going to see here in this demo. Before I begin, does anybody know what DPRA is? Has anybody ever used that? Maybe I'm going to say deployment pipeline reference architecture. Does that ring a bell? No? Okay. That is good. That is not bad. Okay, that is exactly what we want to show here. What we are releasing, what AWS, some contributors from AWS has put together, and this is what we are going to show you. Okay, all right. First things first. So DPRA actually it is a model, again, a reference architecture, and it sets some stages and actions, okay? And what is that? What is a stage? What is an action? Okay, as in other pipelines, we can understand that a stage is actually sets the concurrency, okay? What I mean here is, it's not possible to have like, let's say our pipeline has three stages, okay? And now we can imagine that stage 2 is going to run, okay? It's not possible to have stage 3 running before having the stage 2 completed, okay? So again, concurrency, okay? And actions are actually the tasks that we have inside the stages, okay? So again, this should sound familiar for most of you guys. Some other pipelines use exactly the same idea, okay? And the main purpose of the DPRA is actually to increase velocity, stability, and especially security, okay? So we want innovation, we want agile, however, doing that with security. Fair enough? All right. Here's the architecture of the demonstration that we are going to put together, okay? It uses 4 AWS accounts. The first one is the tool chain. Pretty much that is where our pipeline is located. That's where our pipeline resides, okay? For that pipeline, we are going to use AWS Code Pipeline, okay? And the other 3 accounts, beta, gamma, production, those are the releases. Those are where the application is going to be located, okay? So as we can have an idea, and don't worry about this, we are going to share the links for that, okay? It is a public reference, okay? The DPRA is public, and we are going to show you, we are going to share, I'm sorry, the URL at the end of the presentation, okay? So what is the idea? The code will enter the pipeline, okay? The pipeline is going to verify the code, perform some security analysis, is going to compile the code, and then the first release is going to the beta, then the second to the gamma, and we are going to see that in practice, okay? Finally launching that into production. It is a multi-region setup, all right? So we are going to use 6 regions for the production environment. And finally, while the pipeline itself is built using AWS CDK, all right, the cloud development kit. So the application itself is spread to the accounts using CloudFormation, okay, AWS CloudFormation.
So, Vinny, I want to see this app running. Let's see this application.
Right, fair enough. Okay, so we just said we have the pipeline, but let's go, let's fast forward a little bit here, okay? What is the result of the pipeline? This is our application, okay? It is a simple application. It is a Spring Boot implementation. By the chance, the application source code is Java, all right? That is the one we are using here. And by the way, that application, exactly like you guys are seeing here, it is embedded in the DPRA. So if we download the DPRA from GitHub today, that is exactly the application that we are going to get. We want to use that application, yeah, maybe for testing purpose or even demo, as we are doing here. But the whole idea is go right ahead, take that application off, and replace that, swap that by your code, okay? Put your code into the DPRA and go forward, all right? Okay, so as I said, it is a Java application. It exposes some REST APIs, okay? Quite simple application. It's possible to do some gets, some puts, some deletes, okay? Here we are demonstrating entering a new item, okay? It is an application to list fruits, okay? And we can even delete that, okay? Fair enough. That's it. That's our application, okay? I mentioned that we have, I mentioned that the pipeline is going to deploy the application into the accounts using CloudFormation. Remember that? Okay. Here's the infrastructure that the pipeline puts together, okay, within the account. So we have our application running as a container, okay. That cluster is orchestrated by Amazon ECS. We have some load balancer in front of that, of course, to load balance the requests. And we do the persistence using Aurora MySQL, okay. Again, all of that infrastructure is the pipeline take care of all of that infrastructure, okay?
So, okay, Now I want to see how we can construct it, because I see application running. I want to put my application through this deployment pipeline reference architecture. How can I do this, Vinny?
All right. Okay, so here we have the details of the pipeline, okay? Here we're gonna see the steps, all right? First of all, we say that we have 5+1 steps, all right? And that +1 is exactly the local one. The local one doesn't really run inside the pipeline because, again, the pipeline, we are talking about the cloud, so it's not really in the pipeline. However, yes, we consider that as part of the pipeline. Reason for that is it runs some pre-commit hooks. What is that? Those are actually scripts running on the developer's workstation. And what we want to prevent here, looking at the security side, we want to make sure that, yes, number one, developer gets feedback as fast as possible from the code it is developing, okay? Second thing is, we don't want any possible security event to hit the repository, to hit the pipeline, okay? So for that reason, pre-commit hooks runs inside the developer's workstation. And just to give some more idea here, the things like code quality, maybe as running using check style as an example, could be one kind of analysis is going to be performed. Actually, some static application security testing, SAST, might be using, I don't know, PMD as an example. And finally, verify secrets exposure using Git leaks, okay? A quick quote here. I'm saying a lot of tools, right? So check style, PMD, Git leaks. What is important to mention here, to bear in mind, is that it doesn't really matter which application we are talking here, okay? What is the most important part is, yes, we need to do the security assessments. In case you folks prefer, oh, I don't like Git leaks, I'm gonna use another one, that is completely fine, okay? We are just saying some of the tools here for demo purpose, okay? And it's completely fine to maybe swap that by another one, okay? Fair enough. First step. That is where we hit the pipeline, okay? Where we enter the pipeline. And what is that, Vinny? That is the repository, okay? That is the commit repository we are going to do, of course, the commits to, okay? Then we move to the build phase, the build stage, okay? In that stage, the major action, I would say, of course, we are going to build the code. We are going to compile the code. However, before compiling that, what we want to do, of course, we want to verify the source code. We want to understand things like, maybe I'm going to have another layer of code quality, okay? And this demo here, what we are doing, yes, we have another layer of code quality, and for that we are using AWS Amazon Code Guru, okay? And we're going to have another layer of SAST as well, again, using Code Guru. We are going to assign artifacts. I'm not sure if you folks remember, but Anne said that every artifact that we produce, that the pipeline produces, so it's a good practice to consider, to sign that, to consider some hash for that, okay? So we are going to generate an artifact, a file. So, okay, let's capture the hash for that file. So we make sure that the next stage is going to consider and is going to accept moving forward only if the hashes matches, okay? Finally, it's important to have some software composition analysis, okay? And for that, here we are going to use a Trivy, okay? Trivy is going to perform that. And finally, as a result of the SCA, we have the software build of materials, okay? Fair enough. Let's move forward. Tests. That is the step where we have the first release of our application, okay? So that is, again, the first version of our application. Gamma, it is the second one, the second version. And for that, we can also perform things such as performance tests, synthetics. Here in this case, we are using CloudWatch for the synthetics, okay? And for the performance, we are gonna use JMeter, okay? And finally, DAST. DAST is a key point here because originally the DPRA doesn't have the DAST task, okay? That is something that we have put together for you, okay? Here for Inforce, so we are gonna demonstrate that as well. Finally, ready for production, okay? And before moving to production, what we want to have is governance, okay? We wanna make sure that the pipeline runs, all the security inspections and analysis are done, fair enough. However, we want to move that into production with governance. And for that, we are gonna do a manual approval, okay? Finally, progressive deployment, no big deal. We want to do that, but we want to do that not like a big bang setup. What we want to do is like a more blue-green setup, all right? All right, so this is our pipeline, okay? It's called Fruit API. And here we can see some stages. First one is source. Again, source is where I said we have the repository using code commit. Then we move to build, and here in build we can see we are using code guru, quality. We are also doing some SAST analysis using code guru, Trivi for the SCA. We then build, we compile the code, we use synth pretty much to put the CloudFormation template together. Then we upload the pipeline and generate some artifacts. Here we are using the hashes we said, okay, to make sure that the artifacts are accord. And then we have the beta phase, the beta stage, and gamma, okay? And here in gamma, we have some performance tasks where we are using JMeter. And this is the customization I said we are using DAST. And for DAST, we're gonna do the DAST analysis using OWASP Zap, okay? Manual approval, and finally we have production 0, 1, and 2 to deploy those in different regions. We have some deployment in US and in Europe, and finally in Asia Pac, all right? All right, so I already mentioned that DAST is what we have put together for this event, right? So now we are gonna see that running. What happens is pipeline is gonna launch some computing resources, okay, and that computer resources will analyze the application. However, in order to have that application analyze it, we need to have something in the middle, which is the OWASP Zap server analyzing that. So it will work like this. It's simple actually. Computing resources will access the application through a proxy, and that proxy will be OWASP Zap, okay? That is exactly what we have on the screen, all right? It is the OWASP Zap application server, okay? And through the pipeline, it all runs using API. So in this case here, as we cannot show under the hood, the API is calling, what we are gonna do, we are gonna do a manual scan. It is exactly the same scan that the pipeline will trigger. However, this is going to give you a better look and feel of what really OWASP Zap is doing, okay? All right, so let's get it started. So, not sure if you guys can read, but pretty much what we are going to do, we are going to enter the URL for the Gamma application. Remember, we have put the DAST task after the Gamma release, okay, within the Gamma stage. So we have the Gamma URL over there, okay, and then after entering that, we want to launch the browser. Let's wait just a couple of more seconds here, and it should go through. Okay. All right, come on.
Is it playing?
Yes, it is. I think so, at least. Okay, there we go. Okay, awesome. Okay, so launch browser, and at this moment here, so as Zap is evaluating, is start evaluating our application. We can see our application over here, and right ahead, at the left side, we can see 3 medium alerts, 2 low alerts, and 1 informational alert. Okay, that is just a first evaluation. The alarms. Here we can see some of the alarms. So some informational alarm, medium. For the medium, we are saying that okay, we are lacking some CSRF tokens. Okay, so some cross-site request forgery tokens. And for content security policy, we are missing some headers as well. Okay, those are some not really some vulnerabilities, but some controls that should be in place in order to better protect our application. Okay, and we have all the details about the alarm. We saw 3, but we can already verify that we actually now have 4 medium alarms. Okay, cool. So finally, we now have a list saying that we have 4 medium alarms, okay, 2 low alerts, and 3 informational alerts. Okay, so what would happen is normally our pipeline would fail. Okay, why? Because we could see some findings, because we can see some alerts. Okay, but that all depends on our policy. Okay, maybe maybe we are going to say, okay, it's fine to have informational alerts. I don't want my pipeline to stop because of that. Okay, and now this is the codes. This is the build spec policy for the DAST, where we define that okay, if I have any high alerts, okay, I'm gonna stop the pipeline. Or we want the pipeline to fail. And in case we have any medium, how do I want to treat that? In this case, okay, for the pipeline to not fail, we have put this policy saying, this condition saying, okay, if the medium alerts are greater than 10, so we are going to fail that. So we fail the pipeline, okay? And as we saw, we are only getting 4 medium alerts, okay? So that reason, the pipeline will succeed, and then we hit the manual approval step, okay? During the manual approval, what we get, the approvers, okay, for the pipeline, the authorized approvers are going to receive an email saying, okay, your pipeline is at the manual approval stage, so do you want to go ahead and approve that? That is the kind of email we usually get, and there is a link for that for the AWS console. All right, once we hit that link, so we move to the AWS console and approve that. It will look pretty much like this. All right, so we can see that the DAST and prod, the name here is not really nice, all right, but it is the DAST step. And we hit approve, and we can also enter some comment for that task.
Okay, Vinny, I have a Java Maven application and I want to start to build using all this. Where can I start? Can you help me?
Sure, absolutely. So the starting point for the DPRA, for the deployment reference, deployment pipeline reference architecture is the AWS samples within the GitHub, all right? So once we access that, once we access the AWS samples, we just need to look for the AWS DPRA, okay? And then we are gonna have the, we are gonna hit the repository, okay? That is called AWS dash deployment dash pipeline dash reference dash architecture, okay? The initial setup will look like this. So we have all the steps. We have the README file in that explaining everything that needs to be done. Also the requirements for that. It's really important to bear in mind that we have some of the requirements like AWS CLI, GDK, NPM, and so Maven, okay, as the package that we gotta have installed in our workstations in order to run that, okay? So here are the initial steps, and it goes like this. So we're gonna clone the repository. Once that is cloned, so we want to access that. And then you want to start packaging the code using Maven, okay? We are gonna do some fast forwarding here. It usually takes about 5 to 10 minutes to get everything that is shown here completed. And then after that, we gotta install some dependencies, and for that we are gonna do a npm install. Again, fast forwarding, 5 to 10 minutes later, it's completed, and we are ready to start deploying our pipeline. All right, okay, so Ain, back to you.
Okay, now the security has empowered me. I'm going to show you a little bit of the code. First of all, we talk about the security of the pipeline, and we talk about least privilege. For example, we have some KMS keys to encrypt the artifacts. I am using the code from this example we just see. This is an example of least privilege. I am being very specific, okay, here in the principles and the actions. So if I do not need to have access to any principle in the key, just put the principles you need and the actions that you need. When I talk about IAM roles, also in security of the pipeline, I am also using least privilege here. So I am being very specific in the action and the resource. These things are things that we need to think since the beginning. Do not use wildcards. You are going to forget to fix them later, okay? So it's pretty straightforward and easy to just be specific in the beginning. And for sure, and this is the beauty of you start with code, because we are defining this in the code. Our pipeline are being constructed by code. So another example of least privilege here, the security of the pipeline. We have the pipeline, the code build, need to have access to a specific bucket. We are being very specific in the folder of the bucket and the actions that they are going to be able to perform. Here, in an example of pre-commit hook file, we have here the check styles. We have here the linked to Node.js. They are going to check the code quality. We have the Maven here, and also the Git leaks to detect some secrets, as we saw in the Vinny explanation. Here is the two main folders of our structure, the infrastructure one that built our pipeline and infrastructure using CDK. We have a lot of tests also about the infrastructure itself, and the SRC, where resides our Java application that you see, the fruit pipeline application. In the application, it's a Java one. We have like main and test. And we also have the database code. Remember that slide in the source, secure database, tests, everything should be treated as a code. So we have here on one file because we treat database as code as well. In the infrastructure folder, you are going to have like a lot of tests here, including the secured ones. And here, for example, we have the Code Guru review check. Code Guru is the codes that are going to, first of all, here in the infrastructure, construct the Code Guru all things that you are going to use. For example, code build to talk to Code Guru needs to use a Lambda. And we have here the Lambda codes that we are going to deploy, okay? We also have, for example, Triviscan that are going to do the software composite analysis and generate the software bill of materials. And yesterday, we saw that inspector are going to be a SCA and generate this software bill of materials also in the keynote, right? So here is the pipeline.TypeScript. This file is the file that creates all the pipeline as a code. We have some constructs here, for example, colon Code Guru secured. And in Code Guru, if you are going to see, we have some recommendations there. And here we are calling the security recommendations. Here in the Code Guru quality, there's a constructor where we are going to call Code Guru quality recommendations. I am not going to show you the entire code, but there are some enumerations calling all the Code Guru recommendations. And the Triviscan here that are going to do our software composite analysis. And here is an important tip. Today, you heard a lot about sustainability. An optimal code brings us to a more sustainable world because we are using less resources. So it's something that I want to give you in this slide, okay? When we talk about code quality, it's also important to detect the code that are consuming most resources and if we are able to optimize this code. Also, in the pipeline file, here we are constructing the build action. Actually, there are some dependencies here for the other steps. And the synth action. The synth action from the build stage is the one that are going to generate and put together all cloud formations that we are going to deploy in the next steps. Interesting here, we are creating the build spec of this action through code. You are seeing, like here, the build spec being created with runtime versions, npm install, npm test commands. If you go to the pipeline manually in the console and open it, you are going to see exactly this build file, this build spec file in the build project, okay? You are going to see here the runtime versions, the commands, and here is an output artifact, cdk.out. And here is where we are going to have all the things that are going to be used through to go to the other steps of the pipeline. We have here, for example, all the regions that we are using. We are going to deploy cloud formations there that are going to be generated during the synth phase. And we have here Docker and file asset that are going to be used to Docker and file actions in the next stage to generate the Docker image and put this in ECR. So these files are inside the cdk.out output of the synth action. So we have a pipeline test.TypeScript. We are using TypeScript here. You can use other, but whatever fits to you. Here we are running. It's interesting here because we are testing our pipeline. And we have CDK NAG that's looking for some flaws in the infrastructure, some like if I'm using wildcards, if I have secrets. and is a file that's testing the construct of our pipeline. So here I'm calling this CDK NAG, for example. Here is the output that we have in S3 from the stages. Here is an example of software bill of materials, just a quick piece. And in this one, we can see how far it goes, more than 5,000 lines of code. And we have an example of it found a CVE, and there's a recommendation how you can fix the CVE. You can click here, and you are going to see that a commit fixing the CVE. So this is an example of software bill of materials. If you use code build, you also are going to have these code build reports. You are going to see the duration of the tests and the coverage of the tests. You can also use LCOV. This we have in the DPRA. It's a tool that generates an HTML with the code and some coverage of the tests of this code. There's a new tool that you can use in the command line. LCOV is based in gcov. You can explore this later, just to let you know. And you also are going to have the OWASP ZAP HTML report. And the same way that Vin shows to you, you can click in the findings, and you can see some recommendations, more information about that finding to fix the finding. And this is some pieces of code, and we are talking here about security off and in the pipeline. And now, AWS has solutions to end-to-end development cycle. We saw some of them here, okay? Code build, code pipeline, CDK. Feel free to explore them. We saw a lot of announcements yesterday about new capabilities of some of the services. We also have a lot of partner tools. Take a look in the marketplace. And now to wrap up, I am going to call Vinny.
All right, so here I am back. Okay, wrapping up and coming to the end of our session. 4 key takeaways I would like to share here, okay? So first of all is it's fundamental to consider the pipeline as a code as well. And by being a code, we must protect that as well, okay? We should not only care about the code, but with the pipeline itself. As an example, we need to control which person has access to the repository, okay? That is just the beginning of that. So again, let's have security within the pipeline as well, okay? Then security should be spread all over the stages, okay? So we saw here multiple security layers across all the stages. Understand how DPRA can be of benefit, okay? So the idea is for that to be your starting point, and then we customize that as needed, okay? And finally, we know that an optimal code is the one that is going to consume less resource. And by consuming less resource, we are going to be cost effective and also sustainable. So it's really important to have an optimal code. Some additional resources, I'm gonna leave this slide here for a second. So as I mentioned, if you want to take some pictures, feel free, okay? It references all the architectures and models that we have mentioned here. Okay, ready? Fair enough. And of course, we unfortunately we only have 60 minutes here to talk to you. We know that a lot of code, a lot of tools that we have mentioned here. There are some other sessions. Please join us on those as well, as we can deep even further for the application security subjects. Okay. Finally, call to action. Again, start from the DPRA. That is not the definitive solution. I mean, get that, customize it as needed, and use the tools that better address your needs. Okay? I hope this has been informative for you. I really would like for your presence, and please, it's really important to us if you could respond to the survey, fill up the survey, we would appreciate, okay? Thank you very much.